Welcome student. Now I am going to talk about sulfonation reaction of benzene. Okay, now we will study the sulfonation reaction of benzene as first. What is sulfonation? Here SO3 sulfur trioxide group will substitute for benzene ring and it will produce. This reaction will occur under concentric sulfuric acid, presence of concentric sulfuric acid and 25 Celsius. So what are the products? Substitution product, you know already what will be happen. Substitution will be happen. What is this final product? It will say benzene sulfonic acid. This is the final product. So it is not this much simple. So there is a reaction series to get this final product. So we will study that. So first of all we have to produce SO3. They have only provided concentric sulfuric acid. So by using concentric sulfuric acid we have to produce SO3. So let's start. First thing is we have to produce SO3. This is the theory. Here hydrogen, one sulfuric acid, two sulfuric acid should react to obtain SO3. First thing is here one sulfuric acid. I will draw next sulfuric acid by blue color. What will happen? Here we know in oxygen there are two lone pairs. There oxygen. Reaction will start from one lone pair of a particular oxygen in a particular sulfuric molecule. One oxygen atom contains two lone pairs. One of those lone pair will attack adjacent sulfuric acid hydrogen. It will attack to adjacent sulfuric acid's hydrogen. So this hydrogen and oxygen bond will cleavage towards oxygen. And this hydrogen will bond to this OH group. What will be the product? Black color sulfuric acid molecule. I'll draw like this. Here it's previous hydrogen. And now it contains another hydrogen from this other, came from other sulfuric acid molecule. However, this lone pair attacked to hydrogen. That means this oxygen donated hydrogen. That because of that oxygen get a positive charge. On the other hand, this hydrogen and oxygen bond cleavaged or broken towards oxygen. That broken means this hydrogen will get positive charge. Getting oxygen, getting a lone pair means hydrogen will get a negative charge. This negative charge and forming positive charge will cancel out and it will remain as a negative hydrogen, neutral hydrogen. Neutral hydrogen. This bond breaks towards oxygen. It will produce O minus sulfur, oxygen, OH. These are two products. This reaction is reversible. Okay, that's first step. So what will happen next? We know that this positive charge on oxygen is much unstable. So it will breaks. How? It will break like this. This this bond will break towards oxygen. So I will write in color. This is our HO and this is our sulfur, oxygen. Here it will get the positive charge and water will be formed. Water contain 2 lone pairs. So here plus mark on sulfur, it is unstable. So to get rid of that positive charge, this formed water molecule will help. So how it will help? Here hydrogen, this lone pair will attack to that hydrogen. Because of that attack, this oxygen hydrogen bond will cleavage or breaks towards oxygen. What will happen? This oxygen donated its lone pair to hydrogen. It means oxygen get positive charge and one product will be H3O plus, and this hydrogen oxygen bond will broken towards oxygen. Now oxygen will get the negative charge, and that negative charge means one lone pair that will attack this sulfur. So because of that, it will produce sulfur, oxygen. Because of this attack of lone pair to the sulfur, this positive charge is neutralized. So everything is neutralized. Now we got this SO3 compound. So now we produced this. We can use this product to obtain the electrophilic substitution product of benzene, which means sulphonation of benzene. Okay. Here another product was formed. What is that? This product, this sulfuric acid loses its one hydrogen, so it means in short form HSO4 minus. This means hydrogen sulfate. Hydrogen sulfate formed. So these are the basic things. If I write down the overall reaction here, H2SO4 will all are reversibly form SO3. One product is SO3. Next I erased here one H3O plus. Another one is this hydrogen sulfate, HSO4 minus, here 2. So this is the overall reaction. If you can't see, I will write it outside. So I will write it here. I guess you can't see that. What's going on? 2 sulfuric acids will reversibly form SO3 plus H3O plus. HSO4 means hydrogen sulfate ions. So here this is hydronium ion, this is hydrogen sulfate ion. This is a cation, this is an anion. So these are the product of first category of reaction. Now we got the SO3 molecule, SO3. It is the reactant in electrophilic substitution reaction of benzene, which means sulphonation reaction. So what's going on here? Here now sulphonation. Here our benzene, very stable molecule. I'm not going to talk about that. What's going on here? We have our SO3. Our SO3. What will happen? This sulfur is very electron deficient group. Totally this molecule is electron deficient compound. It needs electron, it needs more electron. Why is that? Because of the electronegativity of oxygen. Oxygen will withdraw electrons from sulfur. So sulfur will be a higher electron deficient atom here. So it needs more electron. So because of this electron withdrawing ability of oxygen, because of its higher electron negativity, it will withdraw the electron clouds towards oxygen, and sulfur gets slight positive charge and oxygen will get slight negative. All of oxygen will get slight negative, here slight negative. However, sulfur will contain slight positive charge. However, very electron deficient compound. So however, this our because of this electron deficiency, our aromatic rings 1,5 bond will heterolytically cleavage towards one carbon and get those 2 electrons for that on that carbon and negatively charged. This will attack for the sulfur, and 1 bond of oxygen and sulfur 5 bond will broken towards oxygen. So what happened? Here this bond broken towards this carbon. This carbon will get 2 bonding electrons, 5 electrons from this on this carbon. Because of getting 2 lone pairs, it will get a negative charge. That lone pair will attack sulfur. When attack sulfur, sulfur contain 3 5 bonds. 1 5 bond will broke towards 1 oxygen, only 1. What will the product? Reversibly, these are the previous 5 bonds. Now sulfur, this group attached towards here. Because of this broken, this 5 bond broken towards this carbon, it will get negative charge. This carbon will be get positively charged. So here it will get positive charge. It's a cation. So now what will happen? Positive charge on carbon is unstable. Now as I said previous video, in electrophilic substitution reaction, in first step this type of reaction will happen. 5 bond will broken and aromaticity of benzene will happen. So here aromaticity of benzene losses in this part. Here benzene is aromatic, here it lost its aromaticity due to lack of 1 5 bond, mean 2 5 electrons, mean it can't conjugate, fully conjugated, it can't form closed 5 electron ring. So it is non-aromatic because this carbon is sp3 hybridized, other 5 carbons are sp2 hybridized. However, because of this 1 carbon is sp3 hybridized, it will lose its planarity, so it will be non-aromatic compound. However, benzene want to regenerate its aromaticity. So what happened? It can't form aromatic, it can't be an aromatic compound all alone. He needs a help. What's the helper? In previous reaction, there was a formed hydrogen sulfate anion. So in this situation, that hydrogen sulfate anion will help to this compound to regenerate its aromaticity. How is that? That HSO4 minus will come near to the, it's already on the medium now. So we know in this electrophile attached carbon contain another hydrogen bond. We know that. As I said previous video, this negatively charged oxygen, its lone pair will attack this hydrogen. This hydrogen will break towards this carbon. This carbon will get this bond pair. So this carbon will be negatively charged. it will attack this positively charged its own carbon. So what will be the product? Now it's regenerated its aromaticity. However, there is a negative charge on oxygen. It's somewhat unstable. In this situation, another one will come to help for this compound to build up final product, our benzene sulfonic acid. So what will be that helper is, in previous reaction, hydronium ion was produced. That hydronium ion will come H3O plus. Here positive charge, here negative charge. Negative charge lone pair will attack this compound. Actually, hydronium ion contain structure like this. It has two OH bonds and another excess OH bond. That's why that hydronium ion got positive charge. So this lone pair will attack on this hydrogen, and that hydrogen oxygen bond cleavage towards oxygen. Oxygen will get this bond pair, and because of getting bond pair, it is negatively charged and it already have positive charge. That acquiring negative charge and positive charge will neutralized. On the other hand, this oxygen contain a negative charge. It will donate its lone pair towards hydrogen. Donating means positive. That positive and negative charge will cancel out and will produce reversibly H bond, new H bond will form. So here this bond pair broken towards oxygen means hydrogen getting a plus charge. Here this oxygen donate his electrons to hydrogen. Hydrogen get this lone pair from this oxygen. Getting lone pair means it get negative charge. Negative charge and that positive charge cancel out and hydrogen will be neutralized. So this is the final product of our, it is the benzene sulfonic acid. All of these reactions are reversible. Now, what will be the next product? Here, hydronium ions, hydrogen will bonded to this oxygen. So, the second product is water. So, this is a reversible reaction. If we remove the producing water from the medium, if we can remove the forming water from the medium, the reaction will be forward according to Le-Chatelier principle. If you remove the producing water from the medium, it will produce more water. Reaction will be forward. That means sulfonation will happen. On the other hand, if we add water into the medium, we can't directly add water to the medium because medium is highly acidic. It contains sulfuric acid, so we will add dilute sulfuric. Dilute sulfuric means we add more water. Because of that water content will be higher. According to Le-Chatelier principle, increasing some participants of a product, reaction. Here, the product form, water is a product. If we increase product side, it will be backward. Reaction will be backward and desulfonation will be occur. Desulfonation. So we can't control the reaction by, if we add water to the medium, reaction will be backward. It will produce benzene. If we remove the producing water from the medium, reaction will be forward. It will produce more sulfonation products. That is all about sulfonation of benzene. Very easy. I think you may understand. If you have a question, please leave a comment. And if you understood this lesson very clearly, please like and subscribe my channel and share to your friends. And if there are any mistakes I made, please kindly comment them. And if there are Any other improvement what should I do? Please suggest. Thank you.